Welcome to this quantum security and defense presentation. AI-supported post-quantum cryptography, and thank you for being a valued member of our community. Peter Clay has more than 25 years of experience in cybersecurity disciplines to include. He has served a number of U.S. federal entities in diverse industries, including defense, numismatics, product development, manufacturing, and the global financial industry. In working with those organizations, Mr. Clay has served as a trusted advisor of executives, boards, and government leaders globally. As a consultant, Mr. Clay enabled several unique security solutions to include the Department of Defense Common Access Card, Department of Homeland Security TWIC system, securing production for the U.S. Mint, security testing for Homeland Security, and the Bureau of Engraving and Printing. In addition to his consulting roles, Mr. Clay has held several security leadership roles, to include Chief Information Security Officer for large global companies, and designed 19 global operation centers.
Thank you. The focus that we're going to be going through is Aireon is a very small global company that operates basically by taking aircraft location information. It's transmitted to spacecraft, the Iridium satellite constellation, and pulled down to ground stations around the world. And then we deliver that out to air navigation service providers, air traffic control organizations, so that there literally is nowhere in the globe anymore that an aircraft can be out of reach or can essentially be lost without appearing on somebody's screen. We demonstrate, we allow for greater traffic flow across the North Atlantic and across the Pacific. We allow for greater fidelity for air traffic control, all over the globe. And so part of what our focus is here is in looking at just doing the single bit of inventory or the inventory process so that we understood what our post-cryptographic cryptography needed to look like, is we really started developing and partnering with people to do 4 functions via artificial intelligence. We're a small company with a big mission. So those 4 areas are, first of all, PQC risk analytics. We'll go into each one of these separately. Inventory and program management is a critical aspect of this. Customized training, one of the biggest areas that PQC programs fall apart, whether you're talking about a big bank or a very small company, is there are so many different stakeholders and constituencies, and you have to communicate with all of them. That can take up all of your available time. So instead of fixing problems, you're talking about fixing problems. And then finally, using this to do very traditional AI DevSecOps to ensure. The other learning that we had when we started doing inventory is we finished our first inventory and we went, great, we finished our inventory, we're really excited, that's great. We fixed several things, and then when we ran the inventory again, just to see what would happen 3 months later, we were actually worse off. And so starting to really understand why those things are and how that's happening, we really had to leverage AI tools to really get a handle on that as quickly as possible. A couple of things to preface everything that we're going to be talking about here. Number one, our approach is artificial intelligence. We're not consuming anything that is publicly available. All of our models are local and on-prem to us. We train them specifically to meet our needs. They're commercially available models, and we're able to pull that information down and build these things out to meet specific Aireon requirements and needs. Number two, we always have a human in the loop. You'll see several different conversations that we have. The ability to automate with AI is incredibly powerful, but you always have to have a human that's able to review the analysis and take the next steps. One of the reasons our PQC environment is challenging is we're a key component of critical national infrastructure for 26 countries. not just one, but 26. Number two, our global attack surface and data exchange is fairly broad for an organization our size. We also have the perception, aviation, and Airbus can certainly speak to this, as well as can Boeing, as well as can every ANSP. We're a high-profile, prestigious industry. When there are attacks and hacks that take place, even for airports that lose message boards, it has significant impacts across both supply chains as well as trust in people getting on aircraft. We work in an industry that has a very long lead time for projects and capabilities. Our IT planning currently goes out, because we're space-based, it currently goes out to 2037, and it's not unheard of for us to go beyond things, go beyond kind of those limits. We also have an incredible gamut of technologies, everything from cloud environments to on-premises to IoT to things in space to literally all around the globe. And so really understanding our PQC environment and doing the inventory and getting our hands around this was a critical step for Aireon's next adventures, if you will. What we're showing up here is what you see on the right is just our externally available assets. This is information you could get if you scanned our environment. For a small company, we were surprised to find that we had 13,767 cryptographic elements to remediate. So one of the things that particularly organizations that are starting their inventory are finding out is there's a lot more cryptography out there than anybody has ever expected. And that's because in a great many ways, organizations have not done a great job of understanding and building and managing these things over time. You don't have to believe me. You can just go and look at the number of times that the failure is caused by a cert that expires to a main website. That's happened to AWS, that's happened to Azure, that's happened to very large organizations you would assume would have their finger on the pulse of all of their cryptography. So when we started really thinking about this and coming up with those numbers, we started by looking outside in. We started at looking internally. What do we have going on internal to our networks and our space? We started also by looking at databases, which are very large consumers of cryptography in a number of different uses. We looked at all of our endpoints globally, because it's not just the things that sit on the endpoints, it's also how they consume cryptography to do far more than data confidentiality, but also the integrity and the availability of data as well as authentication are all blended in there. So for Aireon, with about 150 people, full-time employees, with about another 100 contractors, we do have 22 people that are assigned to this project fairly on at least part-time. As the CISO, I lead it. Currently, we're sitting just over 30% completion on PQC remediation. We would not have been anywhere close to this point without using AI, right? And there's a number of use cases that we're going to go through to really walk that, to really understand that. AI supporting PQC has enormous value in these 4 areas. The risk analytics. When you start talking to organizations about doing inventory, there's enormous confusion among so many organizations about why should I care? I've talked to my brother and CISOs and gotten conversations going such as, this is a problem 5 years from now. I have X number of risks to worry about today. Honestly, the average CISO is in their position for about 2.5 years. That's 2 generations down the road. That guy's problem, not mine, that guy's problem. Number 2, the inventory and cryptographic quality is a critical function. We can't do what we do without understanding our inventory and without making sure that we're remediating all of it. You don't have to be in cybersecurity very long to understand that an attacker only needs to be right once. And if you're at 5 nines, the other 0.0011 or 0.0001 is where they get in. So we're not playing a zero-sum game here. We have to remediate all 13,767 components. And then finally, one of our biggest learnings that we're taking away from this is really understanding that inventory and this process is not static at all. We have developers that are developing. We have to lay out requirements and standards for those developers and how they consume secrets and where they build secrets in and where they build certificates in and how they use the PKI infrastructure and do all of those things. And if we don't, we just get worse with every release. So really making sure that we're able to do that with a fairly small team is a critical function for us. This is the really high-level view of our estimated Aireon quantum threats. And we'll go into kind of how we understand these things at this point. The information that we leverage, you can get publicly, not with the same level of integrity or availability, but you can get publicly from a lot of different sources. So breaking public key cryptography, we worked with a number of different folks to really understand the event horizon. Because the first part of the conversation you'll hear with NIST standards and with NIST conversations out there, this is a 5-year problem, et cetera, et cetera. We don't believe it's a 5-year problem. We believe that either with AI and classical computing or quantum computing with purpose-built quantum machines, the event horizon of this particular threat is 1 to 3 years. Those two numbers, 13,700 certificates to remediate, 1 to 3 years to do that, have become the drivers of our program, right? The second piece of this, and this is something as a CISO, any chief information security officer, whether you're very technical or you're governance, risk, and compliance, or you have the MBA, or you do all of those things, you have to be able to learn to speak and put risk in ways that people understand it. And so what we did and what we started using AI to do is modeling out, if we do nothing, this is how much money Aireon expects to lose by doing nothing. That changes the conversation with the business side of the house very quickly. Suddenly now you're going, well, wait a minute. Here's the impact to the operation system. It's going to take 1 to 3 years. We may only be a year or less away. It may have honestly already happened. And our potential losses look like this if we do nothing. What's the cost of doing something? And being able to model that as your project moves and being able to pull those things together requires some very interesting AI tools that are out there to engage that. We talk risk to business people. So these are the things that we propose. We said, look, if we do activity 1, activity 2, or by product number 1, the blue line that just goes up to year 3 is our expected losses. If we do nothing, that's what we're looking at right there. If we do activity 1, you can see the curve starts to dip significantly. Activity 2, we increase less, but we're there. Or if we buy product 1, we maintain a much lower level of risk. We run this tool on an ongoing basis to provide that feedback to our executives and our board. This is all based upon Bayesian analytics. This is all actuarially accurate, but it's a contextual tool that we use to be able to drive this risk and help our executives understand the risk. So when we talk about AI and PQC, a lot of the things that you're going to hear me talking about today are really going to be about how we prepare our stakeholders to consume this information in a way that makes sense to them. We all speak different languages. We're all separated by a common language in some way. And so risk, you have to be able to present these things outwards. And the tool that we use to do this has really enabled us to get both the resources and the time and the space to actually start to remediate these things. You talk risk tech to techs. One of the areas that we use the MITRE attack and defend process to look at all of the interactions that we have. So we're able to use attack mapping of an attack on a satellite company. You'll notice if you enlarge that, you'll notice there are several pieces of cryptography that were exploited in there. So we're able now to start talking about attack patterns and being able to use contextual information to help our developers and our infrastructure folks understand what this means to them and what are the countermeasures we need to put in place to really understand this. That really started to drive our inventory processes out away from just the beginning process of Pete's a little bit crazy and he's talking about and mumbling about things that nobody really cares about, to wait a minute, these are real problems that are real world problems today that other companies that look like us have, and we need to start to address these things going forward. Inventory and crypto quality support. Everything that we do is based upon playbooks. So we've developed over 30 different playbooks to make sure that we're capturing all of the different inventory components that are out there and assessing those into our risk engine to make sure that we're remediating the right things in the right order. Pulling all of that stuff together, when we did just the analysis of people, we have a ton of smart people here. We would have to have 5 to 7 people doing essentially these calculations full time just to be able to support our program going forward. With both machine learning and AI, we're at about a 95% automation process for these different things. We're also able to break those playbooks down and make sure that when we start to talk about remediation, kind of that third step in the PQC process, we're able to really find the owners of these things and owners of these tools and give them the enhanced information they need, exactly where it is, what it's doing, what it's going on, what data types are associated with it, and be able to pull all that out in a cryptographic bill of materials. So now we're using AI and machine learning to really help our organization understand these processes and understand what they need and what they're supposed to do. The next step that we're really looking at there is starting to do remediation processes and build out kind of our playbooks to go, when you find a cert that is not quantum enabled, not using the appropriate algorithms, et cetera, we want to replace that on an ongoing basis. And we're experimenting with some things right now to be able to automate very simple forms of that to make sure that we're always up to date with those components and pieces. So artificial intelligence as a driver of orchestration and automation is something that we're cautiously moving into, but making sure that we have it fully tested and that we understand it. Lessons learned. Automating stupid produces faster stupid. Don't start automating stuff without understanding the outcomes of it. We work with this stuff in labs. We probably spend 30% of our program resources testing things out and really understanding them in the lab before we ever come anywhere close to a production environment. Always keep a human in the loop. Artificial intelligence is amazing for providing contextual information for a human being to be able to make a better, faster decision. But human beings still need to be in the loop, making sure that everything, all of the contextual pieces are put together before you push the button to just start doing remediation. Test it again, and when you're done with that test again before you automate, right? We changed our entire testing process now that we test to failure. We understand not just is it meeting the test criteria, but understand where the breakpoints are. What are we going to do that will break this, right? What are we going to do and how are we going to do that? Eventually, we will move that into a lot of AI models, but we're building those data models right now. Vivek, I can't give you remote access of my screen, I promise. Finally, it never works when you screwed something up. To say it should have worked is never the right.
Did you try the other shower? No, it's okay. I'm going to leave that.
It should have worked is never the answer that anybody wants to hear. So you have to go through these processes and really follow this as you're thinking about your inventory process and as you're thinking about your PQC process. One of the hardest parts of the program that we didn't expect is the training and communication. It will be a surprise to nobody on here that the standards are not complete. Everybody that thinks that NIST or any other body got the right algorithms the first time isn't following how these things work. It's going to change. The audience for your success is extremely diverse. Extremely. We are talking about PQC stuff with our marketing folks. We're talking about it with our sales folks because they're starting to get questions on this topic. We're talking about it with our executives. We're talking about it with our developers. We're talking about it with our infrastructure folks. We're talking about it with our security teams. All of those groups have to be able to consume this information in different ways for them to be effective and part of the program. A single piece of data triggers all of these different communication and training needs for different audiences. What we have found is AI is incredibly helpful that when we get new data in, we've trained a couple of different AI models that we put the entire data component in, and it's able to do about a 95% job to produce communications that go out to all of these different organizations and different processes to help them understand what we're doing. And so being able to provide that kind of contextual information, I started off my career as a CISO making all of the silly mistakes that CISO makes when they're briefing executives. 20 plus years ago, our firewall got hit 37,000 times, in the last month. And executives are all just looking at you going, is that good? Is that bad? I don't think I care. But when you start to talk about an expected loss in relation to that, the tech guys need to know it. The security guys sure need to know it. The execs want to talk about expected loss. The developers want to talk about what do they need to do and what rules and standards do they need to do, change, modify, get into change management so that they can do this stuff effectively. The infrastructure folks want to know what do they need to change and how do they need to do that. So we're using AI to be able to kind of build one communication and satisfy all of these different groups and all of these different processes. There are still questions. You can't do everything via AI, but you can certainly start to drive a lot of these things out. The final piece of this stuff is integrating AI allows 3 people to become 30 people. In the US, we're right on the heels right now of an event called Salt Typhoon, which was basically the exposure of all of our major telcos to nation state hacking, right? So there's all sorts of crazy numbers that are flying around here right now. I'm sitting in Washington, D.C. today. Our opponents have 600,000 people that are working on hacking our systems all the time. I have a couple questions. How does anybody actually know that? Does anybody publish that? Where is that information coming from? What AI does from a security standpoint is it allows 3 people to be 30. It allows 3 people to be 600,000. So in so many ways, we're using AI right now for automating analysis of both incoming attacks as well as processes and problems going on. It's critical for automating reporting. When you start to look at cybersecurity standards and processes, the low-hanging fruit with AI right now is being able to do so much governance,
Thank you
risk,
for
and
watching this
compliance
presentation,
reporting in an
and thank you
automated
for being a
way,
valued
and
member
that
of our
saves your
community.
people's time for doing much more value-added tasks and processes. It's critical for improved collaboration. If I can write one message about what's going on, and I can publish it in over 150 languages in the context that the user wants to see, that's a very powerful tool from a corporate standard and process. It's a critical piece for our AI risk management is critical for what we're doing and how we're trying to do it. AI today is good for automating services. It's not great, it's good. Good for communication. We still have to have some humans in the loop to be able to provide that. And it's pretty good for providing on-demand support, right? My tech career is basically a long history of me breaking things and having to read the manual to figure out what I broke and why I broke it. Being able to provide that support on an ongoing basis across the board, again, allows me to retask the people I work with to make sure that they're delivering increased value across the board. Our processes are, we will be complete with our PQC processes within the next 18 months, and we'll go into a maintenance mode. We've taken the lessons that we've shared here to be able to do this in a very rapid pace and in a very focused way. And so the things, again, kind of the takeaways here are always have a human in the loop, right? Humans are still great at stopping the stupid that AI can generate, right? Number two, use AI for the right things right now. Generative AI, agents, et cetera, are great. We're not a big fan of sharing all of our internal information that we work very hard to create with the models at large. So we do everything on-prem, and that's allowed us to do a lot of different things that really reduce Aireon's risk for doing those things. And finally, these are not people replacers. These are people enhancers. And it allows us to do these things faster, better, smarter, and cheaper than we otherwise would have been able to do. I think we have about 5 minutes for questions, if there are any.
I have, so thank you, Pete. That was great. And we have a lot of questions. So for those that are not in a hurry, I am ready to stay and take them, if you're gonna take them, Pete. And then there were some also questions for Akash. Okay, so I will get started. Are you ready, Pete, for questions?
Yep.
Are you from Bill? Are you using a cryptographic bill of materials tool as an agent or a third discovery approach? And then there was a follow-up from William, which type of CBOM you're using?
So we looked at a lot of different CBOMs. We've talked to NIST. We've talked to everybody. For what we're doing, as odd as it sounds, the best one, the smartest one that we found is one that's freely available as a standard, and it was created by Banco Santander. That is the most complete CBOM that's out there. We find we use a lot of different ways to discover both certs and secrets and different types of cryptography, because again, we're also starting to remediate our AES and different types we're overhauling all of our cryptography, not just the PKI infrastructure. And so what we found was very specifically Banco Santander's is both extensible and very capable of being able to provide those reports and drive that into machine readable. Because one of the things that we're doing now is we feed these things into our change management system in a very automated way with the human in the loop, as well as into our SIM, as well as into a couple other security tools. So we're able to constantly calculate risk and make sure that we're understanding that stuff. And Santander's CBOM is just the best that there is out there for that.
Right, next question is, are you using quantum-based HSM for acceleration and key storage or a software-based PQC? Is that the next question, I assume? PQC announcement last week, do now or as quickly as you can. No more hurry up and wait. Is that good? I assume that's the comment.
Bill, to answer your question, I have threatened to get Agile cryptography tattooed to my forehead because I don't believe that any HSM yet or hardware solution has the only solution that's available now. I think that this is going to be an evolving risk environment. So we are currently field testing a number of them, but crypto agility, if they can't do it in a way that integrates with both our risk processes and our inventory processes, we're removing them from consideration very quickly. What we have found with HSM models or HSM hardware and components out there is there's some truly amazing manufacturers out there that are doing this in ways that honestly NIST would do well to think about and emulate. There's also what we refer to in the US as a lot of snake oil salesmen, right? That are talking about, I used to make a joke that the fastest way to get kicked out of my office as a CISO was to come in and say, I've created a new cryptography algorithm that I've not shared with anybody, that can't be mathematically proven, but you have to trust me, it works. There's a lot of HSM noise out there right now that falls into that category. And so
I would suggest taking a look at an Ottawa-based company called Crypto4A, where the product itself was built based on the agility required for the new algorithms. He's one of the founding members of the NIST Quantum PQC group, and Bruno holds about 70% of the HSM patents over the last 30 years. So I've worked very closely with him and others. Just in case you haven't come across them yet, they are one to look at.
okay, if you'd put that in the chat, I'll make sure that we get that into the process, because again, so many of these companies ran out of funding or raised money so early that they're starving for anything right now, or they've died. And so we're again, we are part of national critical infrastructure in multiple countries. And so we're being super cautious, not just does the solution technically work, but also making sure that the companies are likely to be around long term, right? And so managing the supply chain along those lines are pretty critical.
There is more question, Pete, if you have time.
Yep.
Is Aireon AI, generative AI solution also suggesting the target configuration architecture for crypto agility for a specific environment, not restricted to PQC algos, but also quantum resistant hybrid setups having combination of traditional cryptography strategies?
We're not there yet. We're moving in that direction. We became aware of some challenges around that in December and had some conversations with NIST, and it became very apparent they hadn't quite thought of those things either. And so this is still a nascent environment that we are trying to solve for. And so we're not there. AI is not giving us that information yet. We believe that from the risk side of the house and locking that in with MITRE ATT&CK and defend, we will be at that level of solution within a year.
Mm-hmm. Then the next questions are, this one is, I've already read that. And then it says, what tool set do you use for PQC? That's from
Abdullah, you can reach me through Anna or Steve. I'll be happy. I don't want to endorse anybody on the call, so I'll be happy to answer any of those questions separately and talk to you about the full tool set and stack that we're using to have this stuff make sense.
Right. Thank you, Pete. And then from Barbara, why developing a C-bomb instead of some type of generalized S-bomb?
Because we started down the process of just thinking this was an extension of the S-bomb, but it became too confusing for existing consumers of our S-bomb to make sure. We wanted the clarity of having the C-bomb and to have it be separate. The other area that the C-bomb has really allowed us to do is to answer incoming customer questions on this topic very clearly and succinctly. We are, ahead. We believe we're ahead of the curve when it comes to inventory, and just in terms of doing it and figuring out how to do it, and we're pretty determined to stay there. And so we really are focused on that And the CBOM allows us to meet those questions exactly and specifically every single time. Whereas the SBOM, they felt like they had to dig through a lot of information to get to the cryptographic bill of materials. It's just, again, it's that communication question. What algorithms are we focused on? That's a very, very broad question for us. We have so many different environments. The only way I can really answer that in a public setting is to almost say all of the D, the classic D question, all of the above. Because we're dealing with IoT and what we put into space is different than what we're going to use for our cooling systems, and what we're going to use for running our lighting systems. And so there are different uses for those. We are working with a number of interesting HSM vendors right now that are giving us a lot of flexibility to get the right algorithms and the right tools for the right jobs. How can I be part of your working plan? Well, Vivek, I think you're going to have to reach out to me directly. Not quite sure how to make that a yes. Bill, are you looking at PQC to do firmware updates, code signing? Absolutely. Code signing, we produce a lot of code. We are definitely looking at this as a process as something that is included in our program and process. In fact, I would say over a third of that 13,700 number that is out there right now is from firmware or aligned with code signing. From Chandra, do you have any documentation available online and open access? We're doing talks like this at this point to provide some open and online access. A lot of the vendors that we're working with, we've done development deals with them that they're able to take the work that we do jointly and take that to market. Several of them are doing that as part of open source. And we will be able to share it via those mechanisms and processes. Anna, I think I've taken up a ton of your time and gone way over time. So thank you very, very much for the questions. You can reach me via Anna and Steve. Thank you so much.
Thank you everyone for all the questions. Thank you to you, Peter and Eckhard, for today's talks. It was great.